Welcome to this comprehensive guide on implementing MVC and MVVM design patterns within the Unity game engine, tailored specifically for beginners. Understanding these architectural patterns is crucial for building scalable, maintainable, and robust game projects, especially as they grow in complexity. We'll start by exploring the fundamental principles of design patterns and why they are indispensable tools in modern software development. Design patterns offer reusable solutions to common problems, providing a blueprint that helps structure your code logically and efficiently. They promote code reusability, improve readability, and make collaboration easier among development teams, leading to higher quality software. Now, let's dive into the Model View Controller, or MVC, pattern, a foundational concept in many application architectures. In MVC, the model manages the application's data, logic, and rules. It's independent of the user interface. The view is responsible for presenting the data from the model to the user. It's the visual representation of your app. The controller acts as an intermediary, receiving user input, processing it, and then updating both the model and the view accordingly. Consider a simple game where a player collects coins. The model would store the player's score and point count. The view would display this score on the screen, perhaps as a UI element of the text feed. The controller would detect when the player collides with a coin, update the model's coin count, and then instruct the view to refresh the displayed score. Here's a basic C# script example in Visual Studio demonstrating a simple model for our player's data. Next, we have the view script, which would be responsible for updating the UI elements based on the model's data. Finally, the controller script ties everything together, handling input and orchestrating updates between the model and view. In Unity, you would attach these scripts to appropriate game objects. For instance, the controller might be on the player character and the view on a UI canvas. A helpful tip for MVC is to ensure strict separation of concerns. Each component should only know about what it absolutely needs to. This makes your code easier to test, debug, and modify without affecting other parts of your application. Now, let's advance to the Model View View Model, or MVVM, pattern, which builds upon some MVC principles but introduces a powerful new component. Similar to MVC, the model in MVVM still represents your application's data and business logic, remaining independent of the UI. The view in MVVM is also responsible for displaying the UI, but it's often more passive, relying on data binding. The view model is the heart of MVVM. It exposes data from the model to the view and handles the view's presentation logic. The key concept here is data binding, where changes in the view model automatically reflect in the view, and vice versa, without direct manipulation. Let's revisit our coin collection game. The model remains the same, holding the player's score and coin count. The view model would expose properties like current score and collected coins that the view can bind to. When the player collects a coin, the view model updates the model, and because of data binding, the view automatically refreshes its display. Here's how a player view model might look in C#, exposing observable properties for the view. The view script would then simply bind its UI elements to these view model properties, often with minimal code. In Unity, you'd set up the binding. This might involve a custom binding component or a third-party library to connect UI elements to view model properties. A key advantage of MVVM is the enhanced testability of the view model, as it contains most of the view's logic without UI dependencies. Now, let's compare MVC and MVVM to help you decide which pattern might be best suited for your Unity projects. MVC is generally simpler to understand and implement for smaller projects, offering a clear separation of concerns. However, the controller can become quite large and complex in bigger applications, leading to what's known as a massive controller. MVVM excels in projects with complex UIs and extensive data binding requirements, promoting a more testable and maintainable code base. The initial setup for MVVM can be more involved due to the data binding infrastructure, but it pays off in the long run for larger games. For Unity, MVVM often integrates well with UI frameworks that support data binding, making UI development more declarative. Ultimately, the choice depends on your project scale, team's familiarity, and specific requirements. Let's cover some best practices and helpful tips to effectively implement these patterns in your Unity projects. Always strive for loose coupling. Components should interact through interfaces rather than concrete implementations. This makes your code more flexible and easier to swap out components without breaking the entire system. Utilize events or delegates for communication between components, especially from model to view or view model to view. Dependency injection can greatly simplify managing dependencies between models, views, view models, and controllers. For MVB, consider using a reactive programming framework like UniRX and Unity to handle data streams and bindings efficiently. Start small. Implement these patterns in a contained part of your game before scaling up to the entire project. Regularly refactor your code to maintain clarity and adhere to the pattern's principles as your project evolves. Always prioritize readability and maintainability. Well-structured code is easier to debug and extend. Testing is paramount. Write unit tests for your models and view models to ensure their logic is sound and robust. Remember, these patterns are guidelines, not rigid rules. Adapt them to fit your specific game's needs and constraints. By applying MVC or MVVM, you're setting a strong foundation for developing professional and high-quality games in Unity. We've covered the core concepts of MVC and MVVM, their implementation in Unity, and essential best practices. Embrace these patterns to elevate your game development skills and create more organized, scalable projects. Thank you for watching. We hope this tutorial empowers you to build better games with Unity.